Bismillahirrahmanirrahim. Dear student, it's me Dr. Mansoor Khan, Assistant Professor, Department of Chemistry, Kohat University of Science and Technology. Today I am going to start a new topic which is based on electrochemical methods. Electrochemical methods is a new course which is assigned to me in this semester. With the title of the course is Electrochemical Method, with the course code CHEM351, and today this is a 21st lecture which is based on electrolytic cell and colorimetric methods. Before directly going into electrolytic cell or colorimetric method, the process of electrolysis is of immense importance. We should know that what is electrolysis. Electrolysis is a process in which the electrical energy is used to derive a non-spontaneous reaction to occur, or simply it is a process in which electricity is used to generate a chemical reaction. In other words, it can be said it is the process in which the electrical energy is converted into a chemical energy. So what is after understanding the process of electrolysis, to know about the electrolytic cell is of immense importance because it is the backbone of colorimetric methods. Because in colorimetric methods we will use electrolytic cell to detect the quantity of the analyte. So what is electrolytic cell? The cell, the container in which the electrolysis takes place, is called electrolytic cell. This is the image of electrolytic cell, which consists of cathode where reduction takes place, anode where oxidation takes place. Both these are immersed in the electrolytic solution and also connected to the external power battery. Now the question arises that what is the basic mechanism of electrolytic cell, or we can say how the electrolytic cell work. It is so important. So the electrolytic cell work can be explained in these few headings. The container in which electrolysis takes place is called electrolytic cell. An electrolytic cell consists of an external power supply which provide electricity to generate the chemical reaction, and second consists of electrode which is made up of metals, graphite, which are immersed in the solution or molten reactants. The power supply, which is usually a battery, is a source of electron. It provides electron to the electrolyte. When a flow of electrons enter a solution of ion, the flow of charge is carried by the movement of ions in the solution. Anion, as we know that ions are of two types. Anions flow in the same direction as the electric current, cations in the opposite direction. So cations move in one direction, anions move in the other direction toward their respective electrode where reduction and oxidation will take place. A compound that conducts electricity by flow of ions when melted or dissolved in water is called an electrolyte. So the solution in which the two electrode, cathode and anode, are immersed are called electrode. So we will take few example of electrolysis in order to understand it clearly. So the first one is a very simple example is the electrolysis of molten sodium chloride. This is the overall reaction of a molten sodium chloride when you immersed anode and cathode in a molten sodium chloride. In this case, the electrolytic solution is a molten sodium chloride, which consists of chloride negative ions and sodium positive ions. Chloride's negative ions are called anions and sodium positive ions are called cations. While anions will move toward anode where oxidation takes place, where chloride ion will give electron to anode and it will oxidize and leads to the formation of Cl2 gas. While the cations, which in this case is sodium, will move toward the cathode where reduction takes place. It will take 2 electrons from the cathode electrode and will lead to the formation of 2 liquid sodium chloride. Down cell is also the example of electrolysis of molten sodium chloride. The cell in which the electrolysis of molten sodium chloride takes place is called down cell, and the images of both commercial and laboratory cells are given as under. So you can use these batteries in laboratory and also for the commercial purposes. Another important example of electrolysis is electrolysis of water, which is also a very simple example, and we have read and we have studied it in our FAC. In anode, where we have seen that oxidation takes place, here the water molecules split up and leads to the formation of oxygen gas and aqueous hydronium ion with the release of 4 electrons, while in cathode 4 electron has been taken by the hydronium ion from cathode and will leads to the formation of hydrogen gas. This is the images of electrolysis of water. Another example of electrolysis is electrolysis of aqueous sodium chloride. Remember that the electrolysis of molten sodium chloride and the aqueous sodium chloride is different from each other. So the first one is the anode. In anode, oxidation takes place where 2 hydrogen takes 2 electron from the anode and will leads to the formation of hydrogen gas, while on the other hand it will take 2 electron also from the end and will leads to the formation of hydronium ion. While on cathode, oxidation will take place where the 2 chloride will take 2 electron from and will lead to the formation of ClCl2 and also the overall. So the overall reaction is given. The end product water formation will take place. Now let's come to the application of electrolysis. So electrolysis application is measurement of the current in amperes that passes through the electrolytic cell in a given period of time. So by measuring the current which is passes through the electrolyte can be used for quantitative analysis. Mass of product formed or reactant consumed. So what are the bases which is used for the electrolysis which is used for quantitative analysis is the mass of product formed or reactant consumed. It is proportional to the amount of electric transferred and also to the molar mass. So charge is basically used to current versus time. So we can take the help of this equation, which is symbolically represented C is equal to A multiplied by S, and this is also another equation in which we use Faraday constant and mole. Another application is corrosion. Corrosion generally refers to as the deterioration of a metal by an electrochemical process. Many metals undergo corrosion, for example corrosion of iron and oxidation of aluminum can be enhanced by atmospheric condition and mostly in acidic medium. Electrochemical process for the formation of rust. This is basically the image where we can show that how the rusting of iron can be removed by using electrochemical processes. Electrochemical process can be used to prevent corrosion by passivation, formation of thin oxide layer by treating with oxidizing agent, formation of an alloy, coating less reactive metals. Now the second part of our presentation is the basic principle of colorimetric method. This is our main goal. In this whole chapter we will discuss colorimetric methods, which is used for qualitative and quantitative method of analysis. So introduction. So a question arises that what is a colorimetry? Colorimetry is an electrochemical method based on quantitative oxidation or reduction of an analyte. In colorimetry, we measure the amount of analyte by measuring amount of current and time required to complete reaction. An electrolytic method is equal to the external power added to the system. So, from the amount of current which is added to the system is basically basis for the quantitative method of analysis. It means if the amount of analyte is greater, high amount of current, external current will be required, and if the low amount of current is required, it means that the concentration or the total amount of the analyte which is to be determined is low. Example, we will take also example for colorimetric methods in order to understand fully the colorimetric method. So the first one is colorimetric titration of chloride. In colorimetric methods of chloride, we take silver electrode to produce Ag. So what silver Ag will immersed in the solution of AgCl2 where Ag formation will take place. Measure amount of analyte by measuring the amount of current and time required to complete the reaction. Electrolytic method is equal to the external, the same like we have studied in the previous lecture. This is the overall reaction. The Ag first converted into Ag ion and then the second is Ag combined with AgCl and leads to the formation of EPT. So the amount of Ag which is converted to the AgCl is basically used for the basis of concentration of the chloride. Another example is measuring of Ag in solution by second electrode. Only get complete circuit when Ag exists in the solution. Only occur after all the chlorine is consumed. So, by measuring amount of current and time required to complete reaction can be determined by the amount of chloride. So, it is the amount of Ag which is consumed will be the basis for the amount of chloride which is present in the analyte. So how the amount of Ag will be when the current is stopped, it means the whole Ag is the whole chloride is converted into AgCl. So from the amount of Ag and from the amount of Ag we can convert the amount of current from where we can determine the concentration of chloride which is present in the solution. Colorimetric methods based on measurement of amount of electricity or charge in coulomb required to convert analyte to different oxidation state. This is another explanation of colorimetric method. This is the equation which is used for which is the base for the colorimetric method. Q is equal to IT for constant current with time, where Q is the charge required, I is the current in ampere, and T is time second. Now this slide shows the types of colorimetric methods. So there are two types of colorimetric method. One is amperostatic method and the other one is potentiostatic method. We will discuss amphostatic method in this our lecture, while potentiostatic method will be discussed in our next lecture. So what is amphostatic method? In amphostatic method, the basic is this is also called colorimetric titration. Like we have early discussed the example of determination of chloride by using Ag using colorimetric method. So that was the example of amphostatic method. So in amphostatic method, titration of analyte in solution by using colorimetry at constant current to generate a known quantity of a titrant electrometrically. Potential is set by contents of cell. This is the example that we have discussed earlier, in which we determined the amount of chloride by using Ag as an electrode. To detect the end point, use electrode titrant. Applications. So the first application of colorimetric titration is it can be used for acid-base titration. In acid-base titration, the neutralization reaction takes place. The titrant and the titrant are, one is acid and the other one is base, while the reaction between the titrant and the titrant is a neutralization one. So this is acid titration, in which H2 will take the production and will leads to the formation of OH, titrant generation, while this one is the base titration, in which the hydrogen ion production will take place. The second application, it can be used for complexometric titration of EDTA. EDTA stands for ethylene diamine triacetic acid. In this type of titration, a complex formation takes place between ligand EDTA and the central metal atom. Here HgNH3y minus 2 is basically the ligand which react with NH4. So, and H4y is y minus 4 is basically is the EDTA, which is used as a titrant, and it is in the 4 and it is hexadentate and it gives 6 pair of electrons. It can also be used for redox titration. In redox titration, reduction oxidation takes place. Here cerium plus 3 undergo to cerium plus 4 by the release of an electron. So the process is oxidation, while cerium plus 3 is an oxidizing agent and is a reducing agent. On the other hand, the overall reaction is given where Ce plus 4 react with Fe plus 2. The Ce is 4 plus 4 is converted into Ce plus 3 and Fe plus 2 is converted into Fe plus 2. Ce plus 4 is a strong oxidizing agent. It leads and it's by itself reduced to Ce plus 3, while it oxidizes Fe plus 2 into Fe plus. Thanks for your patience.